asking that question because that's something very close to my heart. And, I already said in my previous few sentences that the lab is focused on complex traits as well, uncovering the genetics of complex traits. So, 20 odd years of work on complex disorders like schizophrenia, Parkinson's, rheumatoid arthritis, and inflammatory bowel disorders, and looking at global literature. We just realized that no matter what the technology has been over the years, we don't have any answers to the actual genetic determinants of complex traits, which means prediction and prevention, which are the key to genetic disorders and addressing them in a translational way is simply not possible for complex traits. So, since we're talking about technology advancements, we started off with the recombinant DNA techniques, and then we started looking at candidate genes, and then the technology moved forward, and they said, okay, we now have whole genome sequencing information, and therefore we can do genome-wide studies. And from genome-wide studies, they had huge case control comparisons, hoping that they would be identifying the determinants of the disease. Didn't give us any answers. Then we said the routine whole exome sequencing is not good enough. Everything should be whole genome sequencing. We still don't have answers. And now, of course, everybody thinks about artificial intelligence and machine learning as probably some kind of tools which might just give you some answers. But I'm very convinced that what we need to address is really the heterogeneity, both in terms of clinical heterogeneity and genetic heterogeneity, which is a part and parcel of all these complex disorders. Okay?
Sure.
And there is no way as of today with the modern medicine and all of the tools in their kitty to address this issue. Okay? On the other hand, Ayurveda, the ancient wisdom, okay, and the practicing, the medicine which was practiced earlier, which is continuing to be practiced now, has a very different way of looking at health and illness. So the basic difference is, when you talk about allopathic medicine, you're talking about treatment of a disease, which is symptomatic. Whereas in the case of Ayurveda, the whole philosophy is maintenance of health and prevention of disease. So there's a lot of emphasis
without
which is
side
given.
effects.
Yes,
Without
and which is that is what is given the emphasis. And if they talk about maintenance of health and prevention of diseases, that means the principles of Ayurveda already were very different from the symptomatic based modern medicine that you practice. So this is something which we have known, but unfortunately scientifically not validated sufficiently in the case of Ayurveda. But why we were stuck all the time with progress in complex trait genetics and to kind of make anything predictable or testable in terms of using it in a clinical setup, I realized that Ayurveda, with its deep phenotyping principles, which allow Ayurveda Vaid to put people into different categories. Each individual is unique. Genetics also says each individual is unique. But they didn't use the word genetics. They didn't talk about genome components which are coming from the two parents contributing to a child which is unique, except in monozygotic twins. But they call each individual as unique based on the prakriti or the constitution. So their way of assessing an individual allows them to group people into broadly three categories of Vata, Pitta and the Kapha. That's the predominant groups. And then you have a larger majority who have the mix. So you can have Vata, Pitta, Pitta, Kapha, Kapha, Vata and so on combinations. But if you are able to even pick up that small group which is fitting into the Vata predominant or Pitta predominant or Kapha predominant, we believed very many years ago, maybe close to 15 years ago, we actually thought we are quite, probably we will get a lot more insights if we used the Ayurveda principles of deep phenotyping, get individuals put into homogeneous subgroups, and then use all of the currently available technologies to answer the questions on what really underlies what are the genetic determinants of these diseases. So with the limitation that we had with the contemporary medicine and the way that the limitation that we could have, we had no way to address the heterogeneity in any disease, doesn't matter whether it's type 2 diabetes or rheumatoid arthritis or hypertension. The deep phenotyping principle was what I thought was going to give us really some deep insights. So those were the early years. Luckily, we could just kind of, we had an excellent, we still have the excellent collaborator in Dr. Bhima Bhatt, who was an Ayurveda specialist. He worked at Holy Family Hospital for many years, a product of Jamnagar, one of the best Ayurveda schools in the country. And currently he's at Medanta, having opened a department of Ayurveda for this kind of a complementary medicine.
So, did you also practice yoga and Ayurvedic techniques in your daily life?
I'm a regular practitioner of yoga, and I learned yoga, from many different schools. But currently, I follow the Art of Living set of the pranayama, the yoga, of course, and then followed by pranayama, sudarshan kriya, which I think is extremely important for one's well-being and for one's positivity. So there was all these combinations kind of helped, but then the Ayurveda principles really, I think, have the answers, will give you the answers to the limitations which are currently faced by complex trait genome researchers. So that's really, I think, the thing. That's how we started off with Ayurveda traits.
So you got the good result. I mean,
So talking about Dr. Bhatt. So we decided that we will write. He was very convinced that Ayurveda has some of the best ways to address complex traits because they treat each individual as unique. They have recommendations for food, they have recommendations for lifestyle, because they know that each prakriti comes with its own baggage of certain diseases. So if you follow their guidelines, they're able to kind of then, at least you will be able to maintain health. And if by chance you have an illness, of course there are ways to set that balance of elements right, because it's all, we're all a combination of 5 different elements. Somebody will have one element more and less. That's a combination, right? So he was very convinced that we will have answers. And so we wrote a project to the Ministry of Ayush, and we did candidate genes and looked at the Vata, Pitta and the Kapha groups, and we decided, he suggested that we don't touch diabetes, although it's the most common condition, because in Ayurveda, the diabetes, type 2 diabetes, is not called as just one category. There are 20 different subtypes. So you can imagine what happens in a diabetology clinic in a modern medical center versus the way Ayurveda wide actually treats. So he said, if we require a minimum number of samples, diabetes may not be the best, because within a 3-year span, we may not get the required number under each of these predominant prakriti groups. So he suggested Ayurveda clinics see a lot of rheumatoid arthritis patients, because people after a certain period really get debilitated with rheumatoid arthritis, because either they stop responding to the drugs or they're not really taking care. And they all end up going, or most end up going to the Ayurveda clinic for the Panchakarma treatment and things like that. So he said there's a very rich flow of patients of rheumatoid arthritis. So that's how we wrote the project. We got that. We looked at candidate genes, and the results were fascinating. And we published, I think the first paper which we published was in 2012, where we actually showed that there were differences in the genetic susceptibilities between the 3 groups. And then, of course, now in between, I had lots of other modern things which were happening with all my other diseases. But my National Science Chair project is exclusively focused on Ayurgenomics, but not just with genomics, but we have an integrated omics approach where we are looking at genomics, gut microbiome, then we look at urinary metabolome and proteome. We look at epigenome, and then of course the phenome is there. And then we think that if at all this data set is too large, we might also use the AI ML methods to address. So this is really the project which I'm passionately pursuing, and I'm keeping my fingers crossed that we will have some nice insights.
Yes, definitely.
Yeah.